Unit 4, Chapter 1, Storage and Querying. Topics are storage and file structures, indexed files, single level and multi-level indexes, query processing, and query optimization. There are three types of storages in the DBMS. First is the primary storage, secondary storage, and the tertiary storage. The primary storage that is directly accessible to the CPU comes under this category. And secondary storage includes memory devices that are not a part of the CPU's chipset or motherboard, magnetic disks, hard disks, flash drives, etc. Tertiary storage is used to store huge volumes of data. Since such data storage devices are external to the computer system, they are the slowest in speed. Next is the redundant array of independent disks, or in short form, we call it RAID. It's a technology that is used to connect multiple secondary storage devices and use them as a single storage media. RAID consists of an array of disks in which multiple disks are connected together to achieve different goals. RAID levels define the use of the disk array. Next is the storage system in DBMS, in which it is divided into user, DBMS, access method, and finally into the database. As we already know that user operations are expressed via DML in terms of external records and must be converted by the DBMS into the corresponding operations on internal of stored records. These latter operations must be converted in turn to operations at the actual hardware level. Hence, the component responsible for this physical conversion is also called as access methods. Storage system in DBMS. The stored record interface thus corresponds to the internal level, just as the user interface corresponds to the external level. The physical record interface corresponds to the actual hardware level. Thus, the stored record interface allows the DBMS to view the storage structure as a collection of stored files, each one consisting of an occurrence of one type of stored record. Specifically, the DBMS knows the following: what stored files exist and for each one, the structure of the corresponding stored record, the stored record, if any, of which it is sentenced. The DBS doesn't know about the following, which is about the physical records and how stored files are associated to form stored records. The file is a collection of records. Using the primary key, we can access the records. The type and frequency of access can be determined by the type of the file organization, which was used to give for a given set of records. File organization is a logical relationship among various records. This method defines how file records are mapped onto block lists. File organization is used to describe the way in which the records are stored in terms of blocks, and the blocks are placed on the storage media. File structures are piped file method, sorted file method. The pipe file method, in this we store the record in a sequence, one after the other. Here the record will be inserted in the order in which they are inserted in the tables. Sorted file method. In this file method, the new record is always inserted at the file's end, and then it will sort the sequence in ascending or descending order. Sorting of records is based on any primary key or any other key. In the case of modification of records, it will update the record and then sort the file. And lastly, the updated record is placed in the right place. File structures. The pros and cons of file structures are: pros is fast and efficient method for huge amount of data. Simple design. Files can easily be stored in magnetic tapes. Cons is time wasted, as we cannot jump on a particular record that is required. But we have to move in a sequential manner, which takes our time. Sorted file method is insufficient as it takes time and space for sorting records. File structures, heap file organization. It works with the data block. When the records are inserted, it doesn't require the sorting and ordering of records. When the data block is full, the new record is sorted in some other block. This new data block need not to be selected to the very next data block, but it can select any data block in the memory to store new records. Suppose we want to insert a new record R2 in the heap. If the data block 3 is full, then it will be inserted in any of the database selected by the DBMS. Let's say data block 1. Second advantages in the pros and cons of heap file organization is fetching and retrieving records is faster than sequential record, but only in case of small databases. When there is a huge number of database needs to be loaded in a database at a time, then the method of file organization is best suited. Cons is the problem of unused memory blocks, inefficient for larger databases. Suppose we want to insert a new record R2 in a heap. If the data block 3 is full, then it will be inserted in any of the database selected by the DBMS. Let's say data block 1. The file structures next is the hash file organization. In a database management system, when we want to retrieve a particular data, it becomes very difficult and very inefficient to search all the index values and reach the desired data. In this situation, a hashing technique comes into the picture. Hashing is an efficient technique to directly search the location of desired data on the disk without using index structure. Data is stored at the data blocks whose address is generated using hash function. The memory location where the records are stored is called as data block or data bucket. In the same way, when a new record has to be inserted, the address is generated using the hash key and the record is directly inserted. The same process is applied in the case of deleted and updated. Hash file organization. Hash file organization is divided into data buckets, hash function, and hash index. Uh, Data buckets are the memory locations where the records are stored. The buckets are also considered as a unit of storage. Hash function. In hash function, it's a mapping function that maps all the sets of search keys to the actual record keys. Generally, hash function uses the primary key to generate the hash index. So that is the address of the data block. Hash function can be a simple mathematical function to any complex mathematical function. Hash index, the prefix of an entire hash value is taken as hash index. Every hash index has a depth value to signify how many bits are used for computing a hash function. These bits can be addressed to in buckets where all these bits are consumed. Then the depth value is increased linearly and twice the buckets are allocated. In the same way, when a new record has to be inserted, then the address is generated using the hash key and the record is directly inserted. The same process is applied in the case of delete and update. In the hash file organization, there is a method called static hashing. In static hashing, when a search key value is provided, the hash function always computes the same address. For example, if we want to generate address for student ID that is equal to 104 using mod 5 hash function, it always results in the same bucket address 4, and there will be not any changes to the bucket address here. Hence, the number of data buckets in the memory of this static hashing remains constant throughout. In the same way, when a new record has to be inserted, the address is generated using the hash key and record is directly inserted. The same process is applied in the case of delete and update. Now, when we come to the dynamic hashing, the drawback of static hashing is that it does not expand or shrink dynamically as the size of the database grows or shrinks. In dynamic hashing, data buckets grow or shrink as the records increases or decreases. Dynamic hashing is also known as extended hashing. In dynamic hashing, the hash function is made to produce a large number of values. For example, there are three data records, D1, D2, and D3. The hash function generates three addresses, 1001, 0101, and 1010 respectively. This method of storing considers only part of this address, especially only one bit to store the address, so it tries to load all the three addresses at 0 and 1. Now, when we come to the B plus file organization, the B plus tree file organization is the advanced method of an index sequential address method. It uses a tree-like structure to store records in file. It uses the same concept of key index where the primary key is used to sort the records. For each primary key, the value of the index is generated and mapped with the record. In this method, all the records are stored only at the leaf node. Intermediate nodes act as the leaf node. Intermediate nodes act as pointer to the leaf nodes, and they do not contain any nodes. With this, I'd like to conclude my presentation. Thank you.